Bonjour. Bonjour. And I have to switch to English, sorry. I made a promise some years ago that one day I would be able to come here in France and give a talk in French, but this day has not arrived yet. I have to practice much more. And today we're going to talk a bit about Effective Java, particularly Joshua Block just recently released the third edition of the book. And I thought that it was an opportunity because, the first time I read Effective Java, more than 15 years ago, I guess. And after that, I guess a whole new generation of developers came, and some of them lost the way when everybody was discussing the book and the practices. So I thought that it would be a great time to be rediscussing, revisiting some concepts and learning some new ones. I know that Joshua will be himself here at the conference tomorrow, I guess. I don't know if he's here today. But that's another great thing because you get to tomorrow you'll be able to share your doubts with the man himself. And just to have Paul, how many of you have read the book before? Okay. How many of you have read the third edition? Okay. So how many of you have finished the third edition? Okay. I made the same question last week in Boston. We can see a pattern. I think most of us bought the book. We were able to go through some chapters, but we didn't finish. I read the book entirely once for now, but I'm also constantly rereading that, and I have to reread a couple of chapters again for this talk. And my name is Yanaga. I'm a director of developer experience at Red Hat. For those that don't know that, I'm a Brazilian Japanese, not the typical Brazilian you would expect, but I was with my family 2 weeks ago here in Paris for tourism. And everywhere we went, people were saying, "Where are you from?" Brazil. Oh, no, really. No, we're Brazilians, okay? And my Twitter handle is at Yanaga. Just in case you want to follow me, I talk a lot about DevOps, microservices, Java, software craftsmanship, and coding best practices. In fact, I'm also writing a book about domain-driven design and best coding practices. So many of the effective Java concepts that I'll be sharing with you today, I try to apply that to enterprise software modeling. And some of these experiences I'll be sharing on that book. I'm also a Java champion and a Microsoft MVP, which is an unusual combination, but just shows to us that the world has changed a lot. I also work for Red Hat, which I believe is a very cool combination, and I hope that you find that too. And last thing about me, I just recently released this book from O'Reilly, Migrating to Microservice Database. Just in case you want to have a free copy of the electronic version of the book, you can go to this full URL, or if you go to my Twitter profile, the pinned tweet has a link to the ebook. But today we're going to discuss another book, as I said, third edition of Effective Java. If you didn't read that yet, I strongly suggest you to do so, because it's a book that you're going to buy and you're going to read multiple times in your career. I also believe there are some books that shaped the way that I code today, the way that I'm developing software today. And Effective Java, even though it's not a beginner's book, I think it was one of the most important books that I had in my careers as a Java developer. I would put Effective Java, design patterns, refactoring to patterns, refactoring, and clean code. I think these were some of the basic books that shaped the way that I develop software today that I consider very important. So, yeah, I even hope to have an autograph tomorrow from Joshua Block himself. So, another book that was very important, this one I think it's very hard reading, Domain-Driven Design. I think we can, especially the concepts about immutability that we brought from Effective Java, I think they're very helpful to shape this domain-driven design models that we need to use today. So when we're discussing microservices, everybody say that the proper way of modeling, the proper context of a microservice should be a bounded context from the domain-driven design terminology. So I think it's always an interesting reading, even though I think it's not easy to grasp. It took me many years to understand how to apply these concepts properly. But it's an important concept, and again, it's more than 10 years old. We should be discussing more about that. So what are we going to discuss today? Effective Java is a very big book. Would take like 1 week for us to cover everything with the depth that is appropriate to the book. But I chose just some topics. These topics are new from the last edition. So we will be discussing lambdas, streams, optionals, default methods and interface, and try with resources. These are some of the most relevant parts from the new edition. And I also picked up some favorites from me, which I believe that it was the most important when I coded every day in the past 15 years, which were factor methods, try with resources, equals, hash code, toString, comparable, minimize mutability, and enums. If you're wondering what are these numbers in front of each one of these concepts, these are the items from the book. So if you go to 1, 9, 10, and you go to the book index, you'll be able to find the discussions between each one of these items. And enough about that. I wanted to explain to you because showing code in slides is not that fun. So live coding is something I think we should be the most appropriate way of trying to show code. And please stay with me while I try to code some stuff with you. Also forgive me because it's live coding, some things can go wrong. And I've been developing software every day in the past 20 plus years. But one of the bad things in my new role at Red Hat as a director of developer experience is that I don't have the opportunity to be writing production code every day. So, but I believe I can still be productive typing some code. So first, let's start with object creation. Let's try to create a class. So I'll start with a very simple class phone number, which if you're discussing domain-driven design, we would consider this to be, in my model, a value object because it doesn't have identity. And I could replace a phone number with some properties with another phone number with the same properties, and they would mean the same thing for me in my system. If I were modeling a telephone system, maybe that would be an entity, but for now it should be a value object. So a phone number, and some people complain. Of course, I speak, my native language is Portuguese, Brazilian Portuguese. And some people complain that sometimes when I'm talking in English, I speak too fast. So if I do that, please complain, right? On the fly, so I can try to speak slowly. That's what I'm trying to do now. Okay. And instead of having questions all in the end, if anybody has any doubt, discussions, questions, please raise your hands so I can ask and so I can repeat the question and try to answer that because that's a long session, 3 hours. We'll have 1 break in the middle of the session, but you can ask anytime, okay? Feel free to interrupt me. So we're going to create phone number. Maybe I want to have a field called area code. Maybe I want to have another number. I'm oversimplifying here. I'm using just ints in this case. But it's good for an example. If I want to minimize mutability, probably the easiest way for me to achieve that is to type a final in front of that. Then it will complain because I should create a constructor with the initializing these values. Then one of the things that's number 1 item from the book, prefer factor methods. That's what I'm going to do. So I'm going to name a factor method here instead of creating a constructor. You can see that my IDE automatically turned my phone number constructor from a public one to a private one. So I can minimize the instantiability. So only this class would be able to create a new instance of a phone number. I also should perform some validations here when I'm trying to instantiate my value object, because it's much better for me to validate if the input values are correct when I try to create an object rather than later when I try to use the values of the object. If you think about that, most of the bugs that we have in production systems are because, and the harder ones to solve and debug, are the ones that when the system reaches an inconsistent state. Somebody changed the values of my system to an inconsistent state, but since it might have happened today or 1 week ago, it's hard for me to know when or why or how that change had happened. So if we try to validate the inputs whenever we're trying to create an object, our life debugging or trying to solve problems become much easier. So we should be trying to validate the input. Here I only have primitive values, so they will never be able to be null. But if I could check an argument, I like to use a very popular library in the Java space. I like to use Guava. And I know some people blame me for that, because in the past we used to have some incompatibility issues between different versions of the Guava library. So if you ever faced a problem like, well, this library uses Guava 12, and this other one uses Guava 17, and now my project fails because they're incompatible. I know the feeling. I've been through that. But the last readings that I had from the email list were that they were trying to avoid this kind of incompatibility issues in the latest version. But to be very honest, I didn't have the opportunity to try that in my most recent projects. But if anybody has an experience about that, if they fixed this issue in the last releases, please share with us. So here, one very interesting, very nice method from Guava. I could say, well, area code maybe needs to be greater than 100. So I could start import this argument. If the argument doesn't match here the condition, I'll have an illegal argument exception, which is another good practice from the book. You should be throwing this kind of exception for this kind of validation. Number, also check arguments. Maybe number should be greater than 1,000. So that's another thing that we should be validating. If we did it correctly, I can return a new instance of phone number. Some reasons for me to be using a static factory method instead of a constructor. First, factory methods can have names, so could be saying off. I could also be saying create, if I'm always creating a new instance of my object here. From, they're all valid names. I usually prefer of, but that's a particular taste. You could be naming your factor name methods for any, with any name that you wish. Other advantages of factor methods that besides having a name, also factor methods, they don't have to return a new instance of an object every time, because suppose that whenever you pass these arguments, you have a very expensive computation to be calculating, and maybe you want to reuse some instances which were pre-calculated and return the same instance to your client. So in this case, you could be applying the Flyweight pattern. I could be saying, well, maybe phone number, a very common phone number, could be private static final phone number common. Should be like new phone number 123 1234. So suppose this is a very common number, and maybe I could check a condition. If area code equals to 123 and number equals to 1234, return common. Okay? So suppose if you have this kind of computation, you can always return the same instance instead of creating a new instance of your object. It's called a Flyweight pattern. And another advantage of doing that is that if you do this, you can start to compare. If you create phone number of 123 1234, you can come on. You can compare then, and then have another one. Come to. You can compare. Oops. You can compare common instead of using equals. Okay, that's another advantage of using the Flyweight pattern. And another advantage is that you're not restricted to returning just phone number instances. You can return any instance that is a subclass, for example, phone number. So maybe also, depending on your model, you might want to use a phone number as an interface. So we could be creating phone number as interface and creating a static factor methods. Now that since Java 8, you can provide this kind of static methods on your interfaces. We could be using that, so you could return any object that could be implemented in the same interface. But since phone number is a class, I can return instances of phone numbers or any of its children. Okay, so you can also you can change the implementation also depending on the values of the parameters. Suppose that if area code starts from 919, which is from North Carolina, if you could be returning North Carolina phone numbers. If you type like something like 415, you could be returning California phone numbers. So you can swap the implementation depending on the values that you're inputting. Something that you're not capable of doing if you're using a constructor, right? You need to know the type that you want to instantiate when you want to use a constructor. But if you're using a factor method, you have all of these flexibilities. Okay. So these are some advantages of using factor methods. So another regarding minimize mutability, if you're creating a value object, it's very useful if you want to use phone number in collections or in hash maps, for example. Maybe you want to implement equals and hash codes. So which are some of the basic methods that most of the Java classes should be implementing. So equals, we have some properties that we must satisfy to have a proper equals method. So one possible implementation of the equals method could be phone number. They can say phone number, cast, return area code. Okay, and return false. So this is one of the possible implementations of equals. I'm using here the equals operator because I know there are primitive values. But if they were something like object, like if they were in string, for example, maybe I don't want to do that. Maybe I could use the equals method of the classes too. But if I could allow, in some instances, error code to be null, maybe I could just change my code here. Instead of using equality, I could use some method from the JDK, like this .area code, which in this particular case is a bad thing because equals requires objects. And since I'm using primitive values, I have to do the boxing and later unboxing of the values, which is a performance burden. So you might want to think which types are you comparing before using this kind of operations. But if that's an object, it's safe for you to use object equals because it prevents you from doing, well, if this is null or the other is null, so you can have some complex, there's lots of code that is error prone. So you might want to use this kind of comparison method, okay? So which are the properties that you must satisfy when you create an equals objects? I know that this code behaves correctly, but I also want to show you how it behaves. So let's create a phone number test class, and some of the tests, it must be reflexive. Let's see if my equals is reflexive. Let's see if it's transitive. What else? Let me open my cheat sheet here. Symmetrical. Must be consistent. Must be test non-nullity. Okay, I'll just swap this once. And how does it work? Let's see, phone number of 123 1234, which I suppose it's P1. So reflexive means that every object must be equal to itself. So I say that assert true p1.p1 equals p1. If I try to run this test, yes, it passes. So, but if you want to perform an optimization here, maybe depending on the type of object that you want, you have like many properties, and you don't want to be performing object equals every time you're doing that as a reflexive operation. Maybe you want to use objects this return true. That's another way of for you to failing to short circuit your answer. So if you run this again, it still passes. Phone number test. Now it must be symmetrical. So let me try to duplicate here. If I have now I'll call it x. If I duplicate that with y, and y should be equal to x2. So if I try to run these methods, so they both passes, so they're symmetrical. If I want them to be transitive, I can again. And I create another one, z. I know that they're all equal. So assert true, x equal to y. And if y equals to z, then x should be equal to z2. That's a transitive operation. It passes. Now it must be consistent. Let me try. Oh, I should have copy y too. Y. If I do, I should be able to repeat the test many times, and it should always return me the same values and equals. If the values that are being compared didn't change, equals should always return the same value, which in this case is true. Since I'm using immutable objects, it should always return the same result, okay? And it equals is much easier when you're dealing with value objects. If you're dealing with domain-driven design entities, then it's much harder, especially because entities usually use that as JPA entities, so things become harder. And what does it mean as non-nullity? It means that if for any instance of phone number, I should say that it should be false that x equals to null. Okay, let me try to run all of the tests right now. You can see that my equals implementation is correct. It passes all the tests. So we can go back here to phone number. So this is the equals implementation that I've been using the most in the past few years. But if you implement equals, you should always be implementing hash code. If you want to use the quick and dirty way of using creating a hash code methods, since Java, I don't remember, 7 or 8, you can use hash. We can do this dot area code and this dot number, which if you don't care about performance, you could be using this object.hash. The problem with that is that every time you use hash, you're creating an array of values, which is a costly operation. And if you're using primitive values like this one, you're boxing the values for you to perform the hash. But if you know that you're going to be rarely using this instance on a hash set or a key to a hash map, you won't be worried about performance. But if you think that performance is important, you might have some alternatives. For example, if you know that every time you create a phone number instance, it is going to be used as a key to a hash map, or it is going to be added to a hash set. So then maybe you want to initialize the hash code in an eager way. So maybe you want to provide that into hash code. And if you do that, maybe this hash code could be like objects. And this dot number. Oops. Hash. This is one way for you to be eagerly initialize the values. So you could just create hash code, which is one way, but still using this expensive operation. If you go through the book, I won't try to implement that on the fly here. But if you want, the book gives you a very nice implementation of a hash code, especially if you're using primitive values, integer and short. So, but if you want a lazy initialization, you don't want to perform this hash code operation every time you create the object, so maybe it could be lazy initialized. Since it's a primitive, you know that it will be always be initialized as 0, and you can do here hash codes if you can say that int result with hash code. If result equals to 0, then result receives this. Result, turn result, and this function shows the result. Which of course could be improved, but just saying that you can lazily initialize the value of your hash code operation too. So pick up your poison, you choose which is the best way for you to implement your hash code. Okay? So you should be implementing hash code, initializing, okay. Equals hash codes. Another thing is that you should always be implementing toString or objects, because in the past I've seen many people before trying to implement toString methods, for example, trying to provide returning with the toString method some business value to be used as output to the user. But the problem is that sometimes you need to localize the values that you want to show to the user. Sometimes you want to format in different ways. Well, when I'm showing this information to in this form in my web page, I want to format this way. In another web page, I need to format in another way. Some people have been using toString for that. I believe that toString should be overridden always. But the reason for you to be doing that is because you're going to use the toString output of these methods for debugging purpose, right? So the easiest way for you to be using that, now I'm going to use Guava methods. So if you have like many fields in your value object, you probably want to output all of these fields here. And you say this is area code, and you output the area code. Then you can add the number. To add the number, then you say, so this is a proper implementation. Let me again just try to phone number of before. So let's see how it behaves. So you can see that here I have all the output. I can see the fields. I can see the area code. I can see the phone number. And it's a useful information when I'm trying to debug. If I have a logger statement, when I print that out, or if I'm using my debugger, I just roll over the cursor over that. I can see exactly what is happening without having to dig into the object and trying to inspect each one of the individual values. Okay? That's the purpose of this toString. But if you really want to show that, well, this method is not in the book, but digging through the Java API, I just learned that we have a method which was created specifically for formatting values to be used as business output strings to the user. So you could be implementing Formattable. Okay? So if you implement Formattable, you need to implement one method called format2, and on these methods, then you can print your strings to be shown to the user. And how do you do that? Well, you have some flags, some width, some precision. You can choose which, you can pick that, these parameters, which I strongly recommend you to do so. If you want to localize, if you want to internationalize your output, you can also do here. This is the proper. This is the right way of doing that, but if you want to stick to the simple implementation, suppose that I want to output my phone number, for example, as the area code and then a hyphen and the number, and I just say, well, area code, number. And then when I do that, let's see which is the output. So if I just decide to, I want to output that as a string. And whenever I do this, let me try to run again. You can see here that I have a business value, okay? And some of the flags that you have, you can use with precision and flags. For example, if you're producing a text output, you may want to justify the output. You should left justified, right justified. If you have the fixed column a string output, you can do all of this inside the format2 methods, right? So business output, you should usually put in the format2, and debugging output, you should put on the toString methods, okay? Another interesting feature, interface that you could be implementing in your numbers, for example, if phone number has a natural order and you want that phone number to be sorted sometimes in your code, an interesting implementation could be you could create, of course, a comparator, or you can implement the comparable interface. So if I decide to implement comparable, I can just implement comparable phone number, implement the methods compare to, and before Java 8, 9, and 10, I would use the Guava implementation of that, which is a comparison chain. I said start. I could compare this area code, then compare this dot number. So this would be the Guava way. The advantage of doing this is that if in any of the compares, the comparison is not, is just already different. It just short circuit, doesn't compare all the other ones. So this is a performance improvement. But since the latest Java versions, we could be using just the JDK classes. So we could be creating using comparator dot comparing. Since I'm comparing just int, I can use the comparing int. I can say, well, phone number p, and I want to compare first p dot area code, and then comparing p dot number, compare this and no. Okay, so this could be. I'll just remove this. So just using the JDK classes, I can create a comparator here and then compare. But you're always creating a comparator instance whenever you're doing that. So maybe you want to get this and refactor, extract constants. What am I doing? I'll do it manually. I could be doing this, saying that comparator of phone number, comparator. I could be adding here. Comparator. That's a comparator. So this is one of the ways for me to be creating now. I only create the comparator once and always compare using that. Okay? So this is one of the nice additions that we might have. Okay. So what else? Let's try to create here another factor. Already have a main here. So just move it down for me to show. And if I'm using comparator, for example, if I have many phone numbers of 1, 2, 3, 1, 2, 3, 4, then I have this value here. This occurrence is P1. And if I want to duplicate that, P2, and here I have 1, 2, 4. If I have P3, 1, 2, 3, 5. If I want to compare, maybe I can create a collection. For example, one thing that I could be doing, this is one of the nice factory methods that we added to Java. So now the list interface has the factory methods, and you might be wondering why I have so many overloaded instances of lists of these factory methods. Like I have no elements, which creates me an immutable list. I have E1, E2. I have here the vars version. I have multiple versions. And the reason for me, at least one reason for me to be doing that is whenever I have, like, if I have 5 different objects that I want to create as to put in a list, this one doesn't create an array behind the scenes, because if I use the vars version, I'm always creating an array list, an array, which is an expensive operation. So this one it prevents me from doing. But I can't create an immutable list right now because all of this returns immutable lists because I want to sort the lists. So I have to create a list by myself. So I could be using array lists of phone number, or and I want to, oops. Okay, maybe I want lists. New array lists, and I want to build a list.add p1, list.add p3, list.add p2. So I've added lists. Some ways I could be using collections.sort list. It will sort the list for me. Or since I'm using the factory, you see, before Java 8, we needed to have like a special utility class. I had collections to put these factor methods or some utility methods. Now with the Java 8, they can add these methods to interfaces. They just created this way, list off, and I think that's the preferred way of trying to create factor methods. You add that to the interface instead of creating a non-instantiable utility class, just like they did with collections in the past. Okay. But so collections.sort, but maybe I could list.sort. And I could also add a comparator to that. I can provide since I'm in the same class, I could be using the comparator here too. So these are two different ways for me to sort the lists. And if I've done it correctly, you can see that it's properly sorted. Okay, I sorted it twice, and my comparator is working. Or if I added it to a sorted set, for example, it would already order that for me. And that's some of the options that I might have. So, okay. And enough for this code. Any questions so far? No? One common question that arises when I'm using this kind of factor methods is that, well, if you have just only two instance variables, like area code and number, it's reasonable for me to be creating a factor method with two parameters. But what if I have three? Well, three, I think it's the limit for you to be using a factor method, because you have one factor method with three parameters. But what do I do when I have more than three variables to be initialized, or if some of the values are optional? In this case, of course, you have a complex object creator. The best way for you to solve that is using a builder. So let's try to create a builder. So I have a phone number. Maybe I could be creating a person class. And in our case, it should be also a value object, immutable value object, because that's not an entity. And I say that, well, maybe a person can have a title, which is option. Not everybody has a title. Not everybody has a PhD. Can be called a doctor or something like that. Maybe I could say string, but everybody should probably have a name. Maybe everybody should have a surname. Maybe I could have an optional also prefix. Yes. So I could be doing that. Yes. They're optionals. I could also say that they are final. Here in my final value object, I'll be converting to that, but let's try to do this way for now. If I want to initialize everything, maybe I want to create a constructor with all of the fields. And since I don't want to create a factor method with this way, refactor. I don't want to be doing this. Let's create a builder. I know that I have an extract here, but I'll just try to create it through code. So how do we do that? Well, maybe I can create an static inner class, public static class builder. And the builder usually starts with copies from all of the properties that I have here in person. So if I have all of this here, and I know that title, name, surname, prefix, I know that the name and surname are mandatory and title and prefix are optional. Maybe one of the options that I have when creating a builder for a complex object creator is that for the mandatory properties, yes, I can create a constructor, and for this constructor, maybe I can create a factory method, right? So I could be creating a factor method of this, and then from all the properties that I might be able to change over time, which are optional, I could, well, some people prefer to create directly the setters, set title and prefix. Some people prefer to not name that as Java Bean properties, just say title, and just say prefix. I don't have a strong opinion about that one, but one of the things that I do like when I'm trying to use builders is that whenever I have a method that tries to set a property, I just return an instance of the builder itself. So I can return this. So I can have a proper Fluent API. It helps a lot when we're trying to chain the method invocations of object creation. And whenever we're finishing about that, I can also always create public person build. I can have a build method which returns a new instance, new person, and with all of the properties, title, name, surname, and prefix. Okay, is it private? No, so it's a private. I change here to private. Since I'm inside the same class, the builder can also instantiate that, and that's the builder. And if I wanted to check something, well, maybe if the person has a title, it shouldn't have a prefix or something like that. So the right place for you to be checking this kind of conditions is here. Sorry. Here inside the build method. Okay. So maybe you have an inconsistent state. You could be checking the states. Check states. You say that. Title, if title different than null, and prefix different than null. So you can't have both. You should be throwing an illegal state exception or something like that. So this is some of conditions that you should be checking here on the build, and you should be throwing illegal state exception because it's an inconsistent state of your builder. Okay, and just to show you how it works, let's try to create the main methods. Person dot builder off, which we will factor later. Yanaga, if you just create a builder, then you can say, well, prefix. I don't have anything, but I'll say Mr. And I'll say title. It should be no, but it's optional. And I can say build. Okay, I'll be using that. I could omit this, and it should be a proper person. Let's see. Illegal state exception because it's different than nulls. What is wrong? Okay, easiest way to solve it. You see, no more bugs. And now it's showing the person. Since I didn't override to string, it's give me this cryptic thing I should be able to have overridden. And now you get the point why it's so important to override to string properly. So this is one of the ways for you to create in a builder. Maybe some people, instead of off, they just create, and that's what I did before too. Instead of having this factory method here, I could just have a method inside builder. Public static builder, just create this one. And you can have the same parameter here. I just move here to the class. Oops. Okay, instead of builder, just create builder. And remove this one. Okay, so now my code looks like person.builder. And that's usually the preferred way that many people, when develop APIs, when they want to create a builder, they just create person.builder, I pass the mandatory arguments, then prefix, the optional arguments, and then I build. What if I do have too many mandatory arguments? Well, then that's a great discussion. Maybe your value object's too big, you should be splitting that into smaller ones. But if you really have the requirement to have like many of them, then probably should be I don't have a great answer for that, but what I did in the past is if my builder method would have like 3 or 4 mandatory arguments, I would just like break all of them and create like methods for everything, saying like name and something, and then surname, Yanaga, and many other properties, and just check the conditions when I try to build the object. Okay, so I would get a runtime exception. But I still would get an error instead of having a compile time error here, since I didn't pass all the mandatory arguments. But as I said before, I don't have a great answer for that. If you have like 5 mandatory arguments, you have to pick your poison. If you want to have a big methods, which is bad, or if you want to have like many chained method invocations, and you want to check that when you create the object. So these are the 2 options that you might have if you want to create a builder. Okay, and the builder pattern is not only useful when you're trying to create this kind of value objects. Sometimes when you're applying your, if you created an entity in domain-driven design terminology, which is also a domain entity, and you know that JPA entities can't be 100% immutable. But the builder pattern, not exactly the builder, but builder wrapper pattern is usually useful if you want to minimize the mutability of your domain-driven design entities that you have in your bounded context. Okay. So this pattern is very useful. If you just change a bit, just change that to a wrapper, it's still very useful to minimize the mutability. So so we created value objects. We created with factor methods. We've created with builders. And let's just go to the next point, enums. Right? Let me create a new one. So regarding enums, if I want to create a single instance, you know, in the past we used to have like many different patterns. In fact, it's one of the first design patterns that we learn how to create a singleton. Now maybe we could call that an anti-pattern because it makes our code very hard to test. But if you wanted to create a singleton, in the past we usually just create a private static final singleton instance, and just declare the new singleton, right? And we created like a private constructor to prevent instantiability. The problem with that is that you would have to, if your class implemented serializable, you would have to implement the proper read and write methods of the custom serialization to assure that you're not, when you're deserializing, you're not creating new instances. Instead, you're returning the exactly same instance that you had before. So the easiest way for you to be creating a singleton these days, since Java 5, it's with enums. So if I want a singleton, I just create a single field instance. And that should be the way for you to be using, okay? The only disadvantage of singleton is that you're not allowed to inherit from another class. You can't do extends from another base abstract class, which shouldn't be a problem in most of the cases, but it's an enum. Enum is a full-featured class. You can implement as many interfaces as you want, okay? So this should be the way for you to be creating a singleton. But after reading Effective Java, enums became one of my favorite Java constructions. In fact, if you get the Java enum and show that to a C# developer, they will be amazed, because I didn't know that. That's what they told me. I didn't know how powerful Java enums could be, because in other languages you don't have such powerful, because they're like a specific structure, not a full-featured class, just like in Java. So you can have like a very nice things here when you're creating enums. So let me try to create, for example, an enum and call that operation. And if you read the book, you know that when I'm saying operation, I could be creating some operation like add, subtract, multiply, and divide. Okay. And if I want to implement the strategy pattern using an enum, in the past, the best way for me to be doing that could be like public int apply x int y. Oops. And I could say that it's abstract. And if I wanted to implement that, I would need to implement into each one of my enums. I will have to say, well, it's x plus y. It's a subtract. I will have x minus y. I want to implement and here I could have like divide by zero exception. So this is the way that we did in the past when we wanted to apply the strategy pattern in enums, which in my opinion was a very clever way when you have like wanted to limit, like I only want to have these operations, I want to flip them in runtime, which operation I want to perform, and I could override each one of these enums if my logic was small enough to fit inside like this screen. It was a very smart way of doing that, but now since we have since Java 8, we can use lambdas for the same exact operation, so my code would become much simpler than that. So instead of using this, I could have like private final binary operator saying that I want to use an integer. Or if I want, well, int binary operator. Okay. And I can use create a constructor in my enum here. So instead of using all of this, I could just say, well, I pass here to my constructor, and it's asking me, well, I need a binary operator, and saying here that x plus y. Okay, add private final. Okay, let's move. X minus y, multiply. Here. I know you're always already thinking why the code doesn't compile. X slash y. Maybe because that's abstract, so just remove here. Missing. Okay, so instead of doing that way, I can use lambdas and be providing int binary operators whenever I create an enum. So here you might argue, but in my opinion, this is much easier for me to read when the operation is small. Okay. And even if the operation were larger, maybe we could provide like additional, maybe like adding is too complicated. Maybe I would need to create an ancillary class, just a helper class, just to have like all of this code for me to perform an addition. So instead of using a lambda, I could even perform like a method reference to that very complicated logic. And I could say that, well, maybe addition is too complicated. It doesn't fit inside that pretty small lambda. And maybe I could say the public int add y instead return x plus y, and just like imagine that this method could be a very big class with like 50 lines of code, and I could just go back to my operation and say, and I didn't want that to be public, so I could say just class a package priv class. I could say the operation. And I could say, well, I don't want this to be like this way. I could be the addition, add. And in this case, I just forgot that it needs to be static. Okay? So these are some of the things that you can do with lambdas. In my particular opinion, again, my code becomes much clearer when I try to perform my code like this way. Okay. Operators. And since we have these operators, one of the challenges that we have when you're using enums, it's very useful, very powerful. Sometimes we want to map this kind of enums to fields in our JPA entities, and we want to retrieve them from the database and back and forth. So the proper way of doing that since JPA 2.0 is using an attribute converter. And a very nice way for me to go get this back and forth maybe should be like this. I want to, well, add, subtract, multiply, divide. I want to map that to a single char or a single string like A, S, M, and divide. So maybe I want to provide this value final string and say database representation or value. Okay. So whenever I have this, I want to add this constructor parameter. So this now database value, I say this is A, this is S, this is M, and this is D. Okay, so I created this. So I could say public string to database value, return database value. And why I didn't provide a get, I don't like putting get here, because usually when you say get, you're saying that, well, I have a property that is database value, and I'm exposing that to you when I have a getter. And when I use to, if a client doesn't know about the internal representation of my objects, well, basically I'm trying to convert my operation to a database value. So here, I think that the name matters for anybody that is using your API. So to database value, but it's also important for me. So if I have an operation and I want to map that to a database column, I have to database value. But when I want to retrieve the value from the database to an operation, I need to provide a static method that will return me my enum. So what I could do is I provide a public static operation from string value. Oops. Oh, could be. And return something about this. Okay. So, but first, the most efficient way, instead of for me just looking up in all of the instances, I could the fastest way for me to do that is to create a map and then just query the map for the return result. Okay. So that's what I'm going to do. Final map, and I map strings, which will come from the database, to my operation. And I say that this is my value map. And in the past, also before Java 8, I needed a static initializer. I would create a for operation op from my values. Then I would add each one. I would initialize my map, and I would instantiate each one with my for each construction, which it might even be more efficient than the way that I'm going to show today. But now I can do everything just a single liner, initialize everything here. I could be using this construction for a stream off. I pass all the values, and I just collect everything. I can use a collectors to map. And the key of my map, if I have an operation, will be all the database value. And here I return the operation itself. So this is one way for me to be doing. And if I want, I just return value. I forgot to say static. That's why it's not. Value map dot get database value. Okay, which gives me the risk of returning no value, which is one of the discussions that we might have. But since I'm using the get operation, I also have another method here, get or default, which means it could be a database value. If you always have a default operation, you could be returning here add, for example. Or another option that I might have, since I'm using Java 8, could be instead of, well, I don't want to treat the null values here. I want the client of my code to be treating if he or she is handling a null or not. So another option that I have is I could return null, which is not my favorite thing. I could be returning an optional argument. Here, optional operation. So I could say that, well, maybe optional of nullable value map get database value. So this is another option that I have. In this case, the client of my code would be able to handle if the operation is null or not. And how do I do that? Well, let's just create for me an operation attribute converter. Implement attribute converter. And I want operation to string, which is a JPA class. And now it becomes like much more simpler if I have attribute to database value. And if I have a DB data, I can return operation from string DB data. It's an optional. You can say, well, if it returns something, okay, or else I can create something. Well, or else it's going to be operation.add. That's another way for me to handle. And we used to have a bug, but now I believe since JPA 2.1, Hibernate works properly. And your attribute converter is called even if when your value is new. If you have a null in your entity, it wasn't called. The implementation would just leak the null directly to the database and would read the null and pass the null value to your entity back and forth. But now it's properly handled here through the attribute converter. So if you want to guarantee that you never have a null property in your entities, you can do that here in the attribute converter, because these methods are called even if the values are null. So you can convert, you can be sure of the non-nullity of your properties through your attribute converter. Okay, so this is one of the ways. And for me to auto-apply that, I can converter true. So it will always be applied in all whenever I find a property which is of type operation, which used to be in a Hibernate bug, but it's fixed by now too, because it wasn't called for enums, but now it's being called property for all of the enums if you're using JPA. That's another consideration that I have for you. Okay? So these are some of the tricks that we might be able to use using enums, and I guarantee to you, if you show this to a C# developer, he or she will be amazed, because that's a very nice Java feature, and we're glad that we have it. Okay? So we deal with immutability, factory methods, builders, equals, hash code, comparables, enums, singletons. What else do we have to cover? So let me get back for the slides. Minimize, equal to comparable, factor methods, and try with resources, which is a very nice thing for me to do. So let's create here another code. One of the nice additions that we have, oops. Let me show IO. I'll just create a class, and I'll create the methods. So in the past, we used to have this kind of code. So if I had an output stream, out, I would need to try, and out receives a new file output stream, out.text, catch IO exception. And then finally, which self-throws an IO exception. So I would wrap it, oops, out. I would have to close it. Well, I'll just do it the easy way here. which gives me an IO operation. Initialize. So you have this kind of problem. So my code would be very bulky if I wanted to do it the proper way. And I think that's one, since we're dealing with new editions of the Java API, since Java 8, many people were wondering, should I be refactoring or restructuring all my code from the for each code and switch that to streams? Well, in my opinion is that if that was working, it's definitely not worth to be refactoring for that. And this is one of the very few exceptions that I think that whenever you reach the code and you have the opportunity, it's much better for you to try to refactor this code instead of leaving the way it was. So one of the nice additions that we have is that the try is that I can now do this. And I can also create like multiple instances here. Put stream in. Oops. And I can catch it. Exception EX. Okay. And it works properly since both implementations implements auto-closable. Implements closable, it will auto-close every time I... what was IO? Okay, it will automatically close it. I don't need to provide finally or something. This code should work as is, and I can like do whatever I want to do here. Okay. So this is one of the good things that I can use to refactor my code. This one, definitely worth it. Okay. Addition, singletons. Okay. Any questions so far? No? Oh, I have to admit you're a very quiet audience. Because the last time I presented these things, I had a lot of questions. So please don't hesitate to ask. Or the other option is that French developers are simply awesome, which I guess is more likely. So whatever I'm saying is just obvious to you. Okay, sorry. IO. So we just did this, and what are functional interfaces? So now let's jump to the Lambda part. We deal with the basic things, some of my favorite things from the initial parts of the book. So let's try to focus now on the new ones, like functional interfaces. First thing about functional interface, let me show you a bit of the API. If you go to, for example, here, Java IO, Java auto string binary operator here. You want to switch to lambdas. You want to have like you probably be using functional interface for everything. And if you want to be proper using all of them, you know that there are a lot of different functional interfaces that you should be aware when trying to use that in your code. And last time I counted, there were 46 different interfaces for you to learn. But it's, well, I don't expect everybody to like know this by heart, each one of these. But we can simplify because we have like many different variations. For example, you have binary operator, you have int binary operator, you have double binary operator, and so forth. So you can like be simplifying the set that you need to have in your mind instead of having to know all of this. Okay. So, oops. Now let me get back to code. So if I want to create here an operation, I just create an operation. So function. For me to have a functional interface to be used properly in lambdas, this interface needs to have only one method. So if I want public void apply x, that could be. And if I only have one public method, I can say that it's a functional interface, which would help me to use that in Lambda operations. And why I should? Well, I know that if the interface has only one method, I can use that in Lambdas. Why do I need to declare a marker interface just like function interface? I think the best benefit for that is that when you are creating your API, you know that you want to use that as a function interface. But suppose that you're creating a library and the other developers, they don't know about that. And later somebody decides that, well, I don't need only apply method, I need another method called apply. And now I want to overload that X and Y because he or she thought that it would be a very nice addition to your API. And now everywhere that where your code used to use a Lambda, it's broken because it doesn't work anymore. So one of the important things about using function interface is that now my code doesn't even compile because somebody added another method in my interface. Okay? So that's why we should be using markers, this marker interface for the JavaC compiler to be able to prevent this thing from happening. So if we have that, another interesting thing is that, well, I have an int as a return type and also have only one argument as an int. Before creating your own function interface, you should be, I forgot about the item in the book, but you should always be preferring standard Java function interfaces rather than creating one for yourself. And why is that? Because if you create your own function interface, you're adding one more interface for the people that are maintaining your code to learn. And and you already have a very big surface to learn. Like you already have like at least 46 different function interfaces in the JDK to learn. When you're creating your own, you're adding 46 plus your own custom interfaces that you just created. So let's try to reduce the amount of the interface that we need to learn to the basic ones. And if you think about function, if I have an int and I receive an int argument, well, maybe I might have already an interface for that. And if you look at the API, in fact, we do. We have int unary operator, which does exactly the same thing. I return an int, and I have an int as an argument. Okay, so you'll be able to learn most of the. After you learn some of the interfaces, you'll be able to figure out yourself which is the one that you should be using. Okay. Function. And one of the things that Lambdas allowed me to do, which I want to show here with function interfaces, because in the past, when we had like very complex business logic, and we had some steps before or after that business logic that were always the same, the way that we did to implement this in our code was using the design pattern called template methods. So you always created a template method with some operations before and some operations after. And with the operation that used to be different in each one of your case classes, you would create an abstract method and just implement this, the different operations on the children. But now, since we have function interfaces lambdas, it's much better for me to just have a property, which will be a function interface instance, which will be a lambda, and implement just this strategy pattern over the functions. How does it work? So suppose here that in the past, the best way for me to be implementing this in business logic is, I'll create a kit template. I had template business logic. Suppose that I compute, and I used to have like a very complex business operations here. For example, X, Y, Z, and do something, which usually would be the thing that you override, and I had then to be moving my code from X, Y, and Z, and I would A, B, and C. Okay, so you had business operation that was always in the same in the beginning. You had business operations that were always the same in the end, and you had to do something in between. And this is the thing that would change into each one of your children. So you would declare this do something methods as create methods, private void do something, you should say that this is abstract because it's always changing. And this should be an abstract class. Okay. And now that you wanted to vary this implementation, you would create, well, I have a template business logic. Now let's create, oops. Oh, come on. Another class, complex. I have a simple, which extend template. And you want me to implement my methods, and this one would say devox, France, business, simple business logic. If I wanted to have another one, complex, which extended, same thing. Do something, sys out. Who is complicated? English? Something. So I had complex. I also had like simple. And you can see I used to do a template method. But with Java 8, I have a much easier way of achieving the same thing. Instead of have like this multiple classes that I need to provide, I could simply have create a class strategy. Right? And I'll copy the operations here from my template. Like if I had compute. And do something. Instead of doing this, well, now you have to decide which functional interface you should be using. Because instead of creating a template method, I want to call a functional interface inside my code, and it will be provided whenever I create a new strategy business logic. So if it's doing nothing, well, it's consuming, supplying. Well, let's suppose that I wanted to perform some kind of, I'll use a unary operator just because that's the one that we already provided. I'll provide an int unary operator. And suppose that the compute, I'm just using operator dot apply as int 5. And that's the operator that I wanted to use. And since it's complaining, I need to create a constructor. And since it's a constructor, I want to create a factory method. And of course, I could use guavas check or objects dot require non-null from auto, or guava so you get your choice. I believe that whenever we can use the JDK classes, it's better for us to use the JDK classes. On the other hand, if I were to check like the argument using Guava, I'm already static importing preconditions. Maybe I would prefer to just use the same class always. I don't have a clear answer for that. I just say that by inertia, I'm much more used to using check not null from Guava rather than object.require non null, even though they do the same thing right now. Okay? But that's just me. If you're new, if you never used Guava before, I think that check argument is something worth using. But non null, you might want to stick into the objects implementation of that. Okay. And how do you use this class? Well, if I want to perform something different right now, I could be saying, well, let's create a strategy business logic O. And here I'm performing an operator. If I need to perform a lambda, if I'm receiving an I want to give an I divided by 2. If I want to have another different implementation of that, maybe I want to multiply by 4. And if I want to have a different one, also multiply by 2 and everything else. And you can see that here, I'm providing a lambda, which is the part that is different from each one of these cases. If I were using a template method, well, you might be thinking, well, I don't really need it to create a subclass. I could create an anonymous inner class. Here's the code, but I'll definitely argue with you that the code is not as beautiful as it could be. First, and it could be implemented like this, right? Could be implementing, do something, a dot do something. Okay, so this is the code that I could use when using template methods to be able to on the fly generate the operations that I wanted, which you argue is not very readable. And here is the code that I can use if I'm using the strategy pattern using function interface since Java 8. Which leads to me another item of the book. Prefer functional interfaces, lambdas, instead of these constructions whenever you can, because again, I will argue with you that this version is much more readable than this version. And I hope that most of you could agree with me on that. Right? And I think right now we could have a break. Question? Please. How do I handle exceptions here? Okay, that's a very good question. Unfortunately, if my code throws a checked exception, it's harder for me to check with to deal with lambdas. So one option that I might have here, I don't know how many of you have seen this. Vav.io, which used to be Java slang, they have some very nice additions, and some of them they know how they have like a try construction. Then you can use lambdas that calls like throws checked exceptions. This is one of the options. I don't have a clear option because I did some proof of concepts using Vavrio. I don't know if anybody is using that production, but I never had the opportunity to use that in production myself. Okay, but it has some very nice, some case conditions where depending on the type of exception that you get, you can do something specific. So these should be the best answer that I have if you have if you want to use code that throws checked exceptions. Right? But if you can convert your code for code that doesn't throw checked exceptions, I think that it would be much more readable. So yes, checked exception is a common question. And the best answer that I have so far is using a library like Vavri. And I don't know if the Java architects are thinking about adding something to deal with that in future Java versions. I guess they're thinking about more important stuff right now. But as I said, not a perfect answer, but that's the answer that I have right now. Okay. Any more questions until now? No? Then I would like to call a 15-minute break, and we're going to be back talking about more streams. Welcome back. And during the time between these two parts of the session, many people asked me questions, some very interesting ones. So I ask you to please make these questions here loudly in public, because one of the issues that I have in this presentation, it was half already, and I gave more than half of the content. So we have a timing issue. So, and I think I'm speaking slowly enough, right? Or not? I don't know. So, yes, some of the questions that people asked me, my hash code, oops. Yeah. My hash code implementation, yes, it's not thread safe. I know it's not thread safe, but it's a very simple demo and example. So you might want to make it thread safe if you have these requirements. In fact, probably you should anyway. I particularly, in my code, I never had these performance issues that I'm saying about when I had to use hash code. So usually I don't lazy initialize that, but again, that's just me. And another important consideration that I forgot to mention before, but I'm saying right now, is that you've seen that we're implementing equals, hash code, and toString. It's very error-prone for me to be, well, and I have to compare all of these properties. Maybe later, if I'm using a comparator, I need to compare the things in the proper order. I have all of these properties of the equals method that I must be able to satisfy, like if it's reflexive, transient, symmetrical, and everything else. If I implement equals, I should always implement hash code. So there are some. These are the kind of things that should probably be implemented by a machine. So some projects that can generate all of these constructions for you, including builders, are some of them. You can use Auto, which is a project from Google. You could be using Auto to generate all of these methods, builders, and factor methods. And they already implement equals hash code to string properly for you. You could also be using immutables, which is another project that does almost the same. And you could also be using Lombok, which again implements equals hash code to string automatically for you. Deep in my heart, I truly believe that this kind of thing should be automated. But unfortunately, I'm too old. So my first experience with auto-generated code was, for example, with Lombok in the very early days of Lombok. So we had some bugs in production. Thanks to the code, sometimes we wanted to upgrade our IDEs or upgrade our Java version, and we wanted to be in the bleeding edge, and of course, the library maintainers were still targeting a previous version, so things didn't work quite well. So that's my experience, but again, that's a very old experience. All of these projects have matured. All of them are working properly right now. So you're just hearing an experience from, I don't like to say old, but an experienced developer that was burned with some gotchas. But in my heart, I truly believe that should be automated. But how do I say? I forgot the name in English. But I just keep insisting in old practices. And I still prefer just to be tasting the code, implementing my equals and hash code myself. But I strongly recommend that you should be automating these things. And one of the options for automating, as you could use your IDE to be generating our equals hash code implementation. I think that probably this is the worst approach, because usually when you auto-generate, you don't even read the code that it's being generated. You just do it. You don't even know how it's working. And it's very common for you, if you're generating this code through IDE, sometimes you change your code, you add a property, you remember, oh, I have to regenerate the equals, you do that, or something, well, but you forgot to regenerate the hash code, and now your code doesn't behave correctly about that. So if you're going to auto-generate, it's probably better to use Auto or immutables or Lombok rather than using through that IDE. And depending on how wide your team is, and the kind of contributions that you accept, if you're like on a library and you have like people from different teams that you don't have control of everybody. Sometimes using IDEA to generate some equals methods. Other people are using Eclipse. Other team are using NetBeans to generate different implementations, which I'm pretty sure they all work, but it will make your code different in all of the different versions that people are using. So these are some considerations that we might want to have when using and creating all of that. Okay? And moving on. As I said before, some of the function interfaces that we have, like more than 46, but if I think that we've restricted to this 6, unary operator, binary operator, predicate, function, supplier, and consumer will be good because we have many different variations of the exactly same interfaces, and these are the absolutely mostly common when we're using our code. Also when you're using streams, these are the most common interface that we will have to use when creating lambdas. And if you think about that, if you read the unary operator, it suddenly becomes obvious when do you need to use one or when you need to use the other. So you have two different use cases for that. When you want to create an API and you want to choose which interface should I put in as the signature of my methods, and you have the other use case. I'm using an API provided by others, and I want to use some of these function interfaces as lambdas in my code. So let's try to see how can we solve this problem. So I'll open here a class. I just created an array which I'll use to create some streams. I'm using here. So suppose that I want to create an unary operator, which basically, if you go to the interface as we used before, is an operation that we just has one method apply, and both either is applied to a type T and returns the same type. Okay, it's just a standing functions when operator and applying that to the same types. When do I use and when I have the opportunity to use an unary operator? If I go here. For example, I want to create an infinite stream, saying that stream iterate, I want to start with 0. And here you can see I have a unary operator. What do I do to create the next number of my sequence? It starts with 0, and I'm just saying that I could use new unary operator of integer, and just say that, well, I have integer, return integer plus 1. So it starts from 0 and will create for me an infinite stream with 0, 1, 2, 3, 4, 5, or if I want just the even numbers, plus 2, 0, 2, 4, 6, etc. That's an unary operator. Could be using anonymous inner classes, but of course the best possible implementation for me is to use a lambda. So I'm just creating a lambda, and if I don't want to use integer, it becomes much easier for me to be doing that. Okay, so unary operator, I think this is the most common case. I have one type, I return the same type, and I'm performing some kind of operation. Right? So stream.iterate, which will be infinite. If I want to perform a binary operator, I have two arguments. Binary operator. Okay. It stands a B function with the same type, so I have apply. I have two instances of the same type and return 1. When do I use that? The most common case is when I'm applying that to a stream and I want to perform a reduce operation. How do I do that? Well, suppose that I have a stream. It can't be an infinite stream because I can't reduce an infinite stream because it will never end. But suppose I have a stream of, and I provide here some values, 1, 2, 3, 4, and I just want to, well, reduce. All of the streams I have a binary operator. Suppose I want to binary operator of integer. I have two values, and I want to reduce that. Suppose that I only want to have the sum of all of the values. So I integer plus integer 2. And I perform this operation. I'm reducing two values to 1. So whenever I iterate through the streams, I have 1 and 2. I get them, and I have 3. On the other side, if I have like 3 and 4, I just get a 7 in the end, and then it will join. So if I just decide to replace here with a lambda, I can also integer. I can replace for I, or even better, I1, or X and Y. It becomes easier. I can reduce. It will get me a single element, And I can, well, say, or else 10. Let's try to get here for, let me see which kind of result do I get. Which by coincidence, the sum is 10, right? 1. Oops, or else 1. Oh no, that's right. Sorry. So yes, they reduced it. I'm getting all of the elements. I'm adding them in pairs. So I'll get the result. It's 10. It's working properly. Okay. So binary operator. Most of a simple example is in a reduce operation. I have 2 elements and reduce to a single one. Unary operator when I want to create, like for example, an infinite stream. Let's try to perform some operations here. Predicate, function, supplier, and consumer. So let me try to use here. I'll use a predicate. So we use this example. Suppose I'll use this array of strings right now. Stream of, and I get this strings. So I have an array of strings. And maybe I don't want to perform this operation on all of the strings. Maybe I want to convert this stream of strings into a stream of integers, but I know that I can't use integer.parseInt because I have some letters like A, Z, and T, which would give me an exception. So the first thing that I want is to filter the elements of my string. You can see the filter operation requires a predicate, which is something that takes an input parameter, which is of type string, and returns to me true or false. It will be applied in all of the elements. And if it's true, say string s.matches. If my string has 1 or more digits, it will go on the filter, or else it will get filtered out of my stream. Okay, so this is the predicate operation. The next possibility is that I want to convert my string to an integer. So now I have like a 7 string. I want to convert that to a 7 as an integer. So when I want to transform one thing to the other in a stream, I use a map operation. And whenever I have a map, I have a function, right? A function accepts parameters of one type and returns objects of another type. So here I have a string. What I could be doing, I have a string. Parse int, I could s. Right, so I filtered, and if I want to print all of that, I'll use the long version. If I want to do for each on that, let's try to see how it works. So I filtered all of the elements. I just got the ones that matched 1 or more digits. I converted that to an int, and now I'm printing all of that. That matches the predicate and the function. I also could have a supplier, and I can have a consumer, which you can see that as the name says, when a supplier, it needs to supply me something, which means that I have nothing and I want to create something new. And the consumer, on the other hand, I'm giving you some information, and I want you to consume that, which basically, if you're using streams, it's a terminal operation, because it just ends the streams, because I'm just passing the values from the streams and finishing whenever operation I want to. For example, for each is an example of a consumer operation. I want you to get all of the items on my streams and consume them so I don't have any other result. That's why the consumer interface, I just accept a single argument and return void, because that's a terminal operation. Nothing happens after I consume the things. On the other hand, suppose that I want to create something. So whenever I have a reduce operation, because my stream could be empty, if I reduce everything, I could not have a result, for example. So that's why the reduce operation returns for me an optional. And since an optional can be empty, I can have nothing on the the option, I need to get here or else I could provide an integer, or else I could use a supplier, or else get. Because sometimes if I want to use or else, and suppose that I have a very expensive computation, like I have to multiply 5 by 5, and it takes a long time for that. Whenever I call or else, because of the Java evaluation, I'll first compute 5 times 5. I'll get this result. I'll invoke the method, even though it will never be used. Okay? So if that's an expensive computation, I don't want to perform this computation if the optional has a value. So that's why we added the method or else get, where you can give a supplier. And on this supplier, you could have your expensive computation 5. Okay, so you have nothing, and you need to create something. You use the supplier interface, just as using here in the or else get method. So if you have a supplier, go replace with a lambda. Then a supplier is a method that in a lambda I have nothing as an argument, but I return something of the same type, on this case, of the option that I'm creating. Okay, supplies, you have nothing, you create something. Consumer, you have something, you return nothing. So I consider these to be two opposite implementation interfaces. And or else get is one possibility. You could be also using like or else throw, like, because you shouldn't be creating a new exception if you have a value. So maybe you want to create here, and if I want to get the parameters, I could use a supplier. Not throwable, something illegal state exception. From new illegal state exception, you have a string, blah, blah. Okay, so this is one possibility. Instead of using that, you can replace with a lambda 2. Okay? So this version much easier. And I think that with exceptions is even more evident that we should be using a supplier instead of creating a new illegal exception every time, because every time we create exception, we have to get it and dump the whole stack trace and put in that exception, which is a very expensive computation. So in this case, reduce or else throw. If my optional reduce has a value, this supplier will never be invoked, which results in a much more efficient code. Okay? So these are some of the considerations that we need to have in mind when we have any of these, when we're using any of these functional interfaces. The next step is that whenever you can, instead of using anonymous inner classes, you probably should be using a lambda. And whenever you can, whenever it's more readable, instead of using a lambda, you should probably be using a method reference. So method reference, after you get used to the syntax, I believe it turns your code into a more readable state. So in fact, most of the IDEs, they even allows you to perform some refactoring and change automatically your code from lambdas to method reference when it's possible. So suppose here, and you have different kinds of method of reference that you can apply. I have some examples to give to you. For example, here I'm calling this static method from method, so I can have a method reference to static methods, and I just replace lambda like this. Here I have also another method reference. I'm getting this particular instance, system.out, which is a static variable, and on that instance, I want to call this method printline. So I can call method reference on static reference. I also can have bounded and unbounded. And instead of just trying to show, I created an API, which would allow me to show you the different types here. So method static, bound, unbound, constructor, and array. So let me I'll use these static factor methods. So if I have a function and I want to provide an integer, maybe integer parse int is the best way for me to show because I'm using a method reference to a static method. I can also have bound. If I have an instance, for example, I call the bound one. Suppose I want to create, I'll create a lambda first. I have a predicate, so I have an instance. I create a new instance, now is after I. Okay, so this is my lambda. It's even interesting that it's such a complicated lambda that my IDE can't figure out how to transform that to a method reference automatically. But I could be using that instead now. Okay, so I'm creating, now I replace my lambda with a method reference. I just get the instant.now, so I created a new object, and I want you to call the isAfter method on that specific instance that I've just created. Okay, that's a bounded method invocation, method reference. It can also be unbounded, could be like to any any instance. So if I have a unary operator here, I'm receiving a string. So one way for me, if I'm receiving a string, I want string to lowercase, right? So I want to call, I want to replace this lambda to a method reference on that, and I want you to call this method on that specific instance that I just received as an argument. So this one I can refactor it and can use it an unbounded methods reference. I also can use a constructor method reference. Suppose here that I have a supplier and I need to create a new tree map instance. So instead of calling the constructor, I have a supplier. It receives nothing and returns to me a new tree map. This is one way for me to doing that. But whenever I have a supplier, I can just create a method reference to my constructor, tree map new. And the other option that I have is that if I want to create an array, I can also use method reference for array creation. I can here array. Just have in mind that I have a function which receives an integer because that's an array size and returns me an int array. So I can say here, the traditional way using a lambda to do that is that I'm receiving an I and return new int I. Okay, that's the lambda way. If you want to change that to a method reference, you can do this way. So this is the 5 different types of method reference that we can have in the Java language specification. And you might argue that in the beginning it's very hard for you to read, especially if you're not used to the syntax. But after you get used to the Java lambda syntax for method reference, it becomes much clearer what's happening. Okay, so this is preferred than using pure lambda. Other kinds of consideration, for example, let's get back to strings. Suppose that I have here, and sometimes you want to, let me get here a function. Suppose this is a very simple, silly example because it basically does nothing. But suppose that I have a string of strings that I have a function, and I just want, I need to, for example, it's mandatory for me to pass an argument to a method signature, and I want to provide a function that does nothing, that just gets the same object that I'm receiving and return that. So that the simplest possible lambda would be this. I receive a string, I return the same string, which basically says this is doing nothing, so this map operation is useless. But I would say I could be replacing, instead of using this kind of lambda, I could get to the functional interface and call function.identity, which again, it works nothing, but function.identity is what? It's basically a simple function that always returns the same result. Okay? This is one of the very few cases that's better for me to use the lambda than calling function.identity. I think that's saying as lambda s is a much clearer, is much more easier to read than using function.identity, and I hope that you might agree with me too. Okay. So let me see. So these are some of the basic operations when considering lambdas. So now let's get back. We briefly discussed the optional here in the operational. So let's get back to the discussion. Optional was one of the great additions that we had in the Java 8. Of course, we had a lot of backshedding, people discussing if optionals was good or was bad. Unfortunately, I believe there is not a great solution to the null pointer problem, but certainly optional is one of the solutions. You could, we don't have union types in Java, so the possible options that we have for dealing null with our code is either we use the optional class, or we can also use the null object pattern. Whenever you want to return something, you just return a null object which performs nothing in most of the cases. So, but they are complementary. Sometimes you want to use a null object which represents null in your business logic code, and sometimes you want to have an optional operation which might return nothing, and you want the client of your API to be able to handle that. For example, if you create a repository that queries your database and doesn't return, you can return a customer, or you might not find that customer in your query. Maybe optional is a very nice, it's one of the use cases where optional is better than a null object, because your business domain might not have a null representation for a customer. Okay, so you use an optional for that. How to create an optional? If your optional can be null, the way for you to create an optional instance is option of nullable. If you want to return an empty optional, the way for you to be doing that is optional.empty. On the other hand, if you know that you have a value, but you have to return an optional, you can return optional of and operation dot add, right? You could be returning that too. And of nullable, if you don't add, you should never, if you have if you have the option to be returning an optional, you should never just get and return null, which is probably the dumbest use case that you could create. Like you changed your method signature to be an optional, and you're just returning null because you don't want to do that. You want people to have no pointer exceptions, right? So you don't never do that. One of the possible disadvantages of the optional class is that optionals are not serializable. So it means that if you have an object, you must be able to serialize, which, as the book discusses, most of the cases it's a bad option. But so optional can't be used as a field instance on serializable classes. If you really want to have an optional field on your class and you want that to be serializable, you have to create your custom read or write object for your serialization, or create a serialization proxy, which is something that I've done in the past too. Or let me create another class to exemplify that. Suppose that you want to create a class customer, and you want that to be serializable, and now you decided that you want to have a field optional string title, right? Doesn't work if you use just basic serialization. If you try to serialize that, when would you use that? Suppose that you have a customer, you just queried that implementation from your database, or you create a new instance, and basically you want to store which customer is logged in your session, which could be a bad choice too, but well, we like bad choices. So we just get this customer, but that in our session, and whenever they try to serialize that to a cluster, or we want to update our version, we try to serialize to disk and back and forth, we have an error because option in this case is not serializable. Better approaches would be, well, not use optional for that. If you want to store the customer in your session, maybe it would be better for you to just store the customer ID and then query that whenever you need it instead of storing the object. That's one option. But if you really want to do here, maybe you could say, well, private string title, maybe you could put a beautiful Java doc saying that this could be null and not a getter, instead of having get title, instead of returning string, you could say optional, string, and optional of nullable title. So if you really want to use optional, maybe it's better for you to, well, just use a plain old, use other type, just document that it can be null, and you create optional here with off nullable, which can be useful with some, depending on the API that you're creating. But if you're trying to use customer, for example, which could be an entity in your domain model, it's usually a bad choice because optionals are not supported in the Java Bean specification. So you won't be able to use that in your beautiful frameworks for automatic mapping of properties. Okay? If you're using any kind of view framework has some kind of binding you from the view to the properties of an object. So with optionals, it won't work properly. Right? So these are some of the considerations using optionals. And one other consideration. I have a new customer, get title, I have that title, and this is the same thing that I've discussed before. Sometimes I have an optional, and it did this, or else throw, again, supplier is particularly useful for you to generate supplier here, to not create an exception every time because of the stack, the cost of the stack trace. So, or it's a very nice example of using a supplier with optionals. Okay, method reference. What did I cover? Here's the exception. Okay, yes. Another, this is new, and we had some very nice discussions on the Java Champions mail list last week, because now that we have Java 10, we have like a new addition to our vocabulary. So we have, we can do nice things like this. var I receives 5. And now it works. It compiles. Okay? It's not dynamic typing because I is still a primitive int. But if I had like a string, var s receives devox. It also works. It's not like in JavaScript because when I create s, I can never change the type later for s to 4. It gives me a compile time error because I'm changing the types. So basically, it's just preventing me for typing a string s. So one of the discussions that we're having is when should I be using the var approach or when should I be using the typing approach? And I had my own personal opinions, but it was very nice to see like the opinions of the other people, such as other Java champions, or when should I be using one or when should I be using the other one. My particular opinion, which is not covered in the book yet, is that var is not that useful if you have like instance properties. Suppose that you want to create a private int I equals to 5. Here, if I want to declare that var is not that useful, in fact, it wouldn't even work properly. So, or sometimes I want to use var I, and I want to create a new instance of an object. Well, maybe new buffered reader, and I want to create a real new file input string reader. File reader. Am I doing it right? Yes. So that I don't have to type all of this. And the best conclusion that we had, it was the opinion that I had before. If you are creating a new object and you would be repeating the same string on the left and the right assignment, maybe var is a good approach. But if you're calling a new method, that this method could return something different, like, let's see if I have an example here. String, create something. You shouldn't be ABC. This is what we consider a bad approach for using var, because it's not explicit which is the type of string. Sometimes if you want, maybe you have to look at the signature to know, well, oh, it's returning a string, so var is of type string. But if you're creating something like this, like I want to create a tree map of integer, then string, map, new tree map. If you're doing this, then I'm repeating tree map on both sides. Thanks to Java 7, I don't have to, with the diamond operator, I don't have to type this again. I can simplify. If I'm doing that, then maybe var is a nice addition. Maybe instead of typing all of this, I could be typing this, new tree map. So my opinion is that this is one of the very nice use cases where using var is better than using just the more verbose syntax, because you can explicitly see which is the type that is being created. You're not missing any kind of information. So I think it's even more readable when you say var map to receive a new tree map. But that's the use case that I think it's very useful. And the other ones, well, this one I don't like particularly, and this one, it's discussable, okay? So these are some of the discussions that we might have with var. Yes, please.
What is the type of map to? Because usually we want to have the
If that's map or tree map? Yeah, in this case it's tree map. Because you should always be using the most generic type. Yeah. Well, as I said, I don't have a consensus about that, because you could be creating this, right? Map, integer. Right? Instead of creating var, then it will be bounded to tree map. You have the most specific type instead of the generic type. One of the arguments that usually when you're using that is just local scope. Like you're not leaking the implementation to outside your methods, so you wouldn't make much difference anyway. So, but yes, that's another example of discussion that we had on the mailing list, for example, right? But my argument here is that you're using var just for internal, like inside your methods. You're not leaking it anywhere, and it shouldn't hurt. Because if you were to return this, I would create a method like this. Then if I were to create web map, new tree map, right, so this is one of the possible use cases that you'll be using. Then your API is still bounded to the interface instead of the implementation. Okay? So, but that's a very nice question. Thank you. Any other questions? No? As I said before, you're just awesome. You already have an eye. So I'll try to finish this one. Okay. So this covers the basic, but since we still have time, I'm going to dig a bit further into the object creation, because for me particularly is one of the most useful things. So let me get back to person. And as I was describing, because I described a bit of immutability, but I didn't cover all the use cases because this was very simple. In the end, a string is an immutable class, so it's not the typical use case that we find in business objects. Sometimes the objects that we're dealing in our domain model are mutable, and we want to minimize mutability. We want to create defensive copies everywhere. We want to have, if you have a business object that has a list or a collection of other properties, we have to deal with that. We have to copy the collections whenever we can. We need to provide immutable copies whenever we can for consistency reasons, and that's a part that we're going to cover right now. Okay, so we still want to minimize mutability, but suppose that I want, I think it's easier for me to create another object. Suppose that I want to create an order class, and this class has a property called date, which you should be using really, because now that we have Java 8, we have the new date and time APIs. Would be much better, but date is nice because date is mutable. You can change the date after an object is created. And if you want that, even if you instantiate that as a final, and you create a constructor and everything else, let me try to create a factory method. Of course, do checking. Check not null. Check not null. Oh, I'm missing my. Did I mistype? Check not null. Where is my Guava method? Okay. Require null date. Return order. And if I do that, it's not safe because since date can be changed, after I created, my object is still mutable because the value of my date could be. So what do I have to do here is that I need to create a defensive copy of my object as I'm passing here. So require null objects this dot date. Probably I should create new date, and I can pass as a parameter long date dot get time. So I'm just creating a defensive copy. It's mutable. And if you want to check if maybe date needs to be in the future or date needs to be in the past. If you want to do some kind of assertion, you probably want to do this kind of assertion after you made the defensive copy, or else you might have like a race condition where, I just checked that, and then I'm attributing this date to my instance field, and somebody already changed the data before. Okay, so you want to perform first the defensive copy, and then check the values on the copy that you have, because then you know it won't change anymore. Your class is still not immutable, because if I just provide a getDate methods, this date that I'm returning is still mutable. So here again, I should be always returning defensive copies. So even if somebody changes the return that I've given in this getter, my internal value will remain unmodified. So this is one of the ways for you to create a proper immutable object when you have to deal with mutable properties. Okay, it does not only apply to simple types. If you have a collection type, you should be able to be performing the exactly same thing too. So suppose that I have an order, and then my order has some items, and I'll call that order item. I'll create an array list, just no. I need to create a class, okay, which is immutable by now. List. Okay, so I'll add this parameter to my constructor. Private. I'm getting it, so I should be providing this on my factory method, list items, order item. And you know that since you're receiving a list, you don't know if that's a modifiable list, you don't know if that's an unmodifiable list. So this, again, the same way that list could be changed, you should be providing a defensive copy of that. And probably, if you know that you won't be changing your list internally anymore, you could be providing an immutable list implementation here. But since I'm not sure about that, and since it's not that useful, if you're modeling order, for example, as a JPA entity, you need you will have a mutable implementation whenever you query your entities from the database. So what you could be doing that, you need to provide a defensive copy of the items. So order date, and you pass here. You could be copying here as I did in the constructor. Or you could be providing the defensive copy here, which makes your constructor code even more simple. Okay. The bad thing of doing this is it's the checking of the arguments would need to be done here. Okay. And here I need to provide a copy. I need another instance for that. What could we do? A new array list. I had another collection, and I provide here the items. Okay. So I'm providing a new instance, which has the same order. Again, is not 100% immutable because I must assume that order an item could be changed. Okay. It's very hard for me to when you have business objects as entities, JPA entities, it's very harder to model properly as immutable, but you need to minimize mutability whenever you can. So even though I can't guarantee that the order items won't change, I'm doing whenever I can to guarantee that at least the list won't change. At least the order will be maintained. At least the items that are on the list will be maintained and everything else. So another option for me, if we're using JPI, for the order item, it would be to change order item instead of being an entity. I would change that, which means that it has an identity, it would need an ID and everything else. I could model that, for example, as a value object. I could model that as embeddable, which means that it doesn't have an identity. It could be replaced as I wish to. So, but that's a JPA discussion, which is very different from the one that we're having right now. And now that we have a list of items, if I want to perform an immutable, I need to perform a defensive copy. So if I get items, I could also be creating a new copy. Or the items, or I could use my favorite approach is that, again, we're going to use a Guava class for that. Could be immutable list dot copy of, and I can pass the items. Okay, so I'm returning an immutable list implementation because if you return, for example, just a new somebody would be tempted to be performing change operations on the copy that you performed. It won't affect your order object, but somebody might be thinking, well, that I really changed the order, objects. On the other hand, if you provide an immutable list, just like I did here, if anybody tries to perform a modifying operation on my list, you will get an unsupported operation exception. For if somebody tries to add or remove or something like that, which is very good because if you think about the property of encapsulation, the only class in the system that should be allowed to change the items on my order should be the order itself. So if you need to enforce some invariants in your code, you would need to put it here. inside here. So if I wanted to add an item, I would probably add item, order item. I would need to be doing that. If I would need to remove an item, I would probably need to add a method here, and that's the proper way of dealing with it. Okay? And since once you get used to these immutable list implementations, and now that we have Java 8, we have streams, I always wonder, well, in the Java 8 API, we have the collectors for us to be creating lists, maps, and everything else. If I want to, but if I wanted to create an immutable implementations for the collections.unmodifiable list or a modifiable set or something like that, I would need on the collectors, I would need to concatenate or perform some custom lambdas about that. That's why I decided in the past, let me get here back to my operation. You see, and the best way that I found to make, I wanted to value map to be immutable. I didn't want it to be a mutable map, even though I never change it after it's created. But if I wanted to guarantee that this map is immutable, I would probably need to add a modifiable map, or if I'm using Guava, I could use an immutable map implementation. So instead of chaining collectors or using a custom lambda for that, I just decided to implement in another class, more collectors, to immutable map. I just created another implementation of collectors, which basically, I just created a class for myself, more collectors, and I created here two immutable map, which is has a lot of generic keys, but basically I'm creating an immutable map implemented Guavas, immutable map implementation, which is unordered and unconcurrent and everything else. Okay, and this code I released that on Maven Central, but this code is very simple. Of course, anybody could just implement it by itself. I just happened to implement it when Java 8 was released because I really wanted to use the Guava collection classes. So I just create this Guava stream library and release that to Maven Central. And again, it's Apache licensed. You could use that. I've been using this in production for a couple of years right now. Okay, so now you know that it's an immutable operation. Okay. Any other questions? Discussions? Okay. Well, I know that we still have 30 minutes, but that's the content that I wanted to share as an university session. I was really hoping that you had like hard questions for me to be able to answer, but if nobody has any questions, we could call it a wrap. But I already want to say thank you very much for being here. Any questions? Oh, please. Okay, so that's two questions, right? First, why can't we have, like in the collectors of the JDK, a collector that already returns a modifiable list, or, well, that's a question that should be answered by the JDK team. They could, but they didn't. But of course, if you just argue, there are a lot of methods that should be implemented, but they are not. And I guess that sometimes they don't implement because they have a lot of things to do. And you always could create another method, so they always discuss. And think about the JDK maintainer. We don't create all of the methods that we think that people will use, because after we create something, and Java is very good on that. Java maintains backward compatibility. Anything you put on the JDK, you have to keep it forever. So that's why they must think like 10 times before adding any method to the JDK. Another consideration, for example, why the things that I said about the optional, that you can't use as the field because it's not serializable if you have a serializable entity. And they did that on purpose because serializable classes are a pain to maintain. So they didn't want to have that burden, and then probably would want to change the implementation option in the future. If it was serializable, it wouldn't be possible. And if there is a nice talk about Stuart Marks, which was even recorded at Devox, where he discusses all this bike shedding about optionals. And one of the points is that after we get value types inside the JDK, they might want to consider to change optional to a value type. So, but if they created as a serializable class, it wouldn't be possible to change later. So this is one of the discussions. And the first question, I missed that. Yeah, is this one? Okay. Thank you. Anything else? Oh, as I said, you are already great. Oh, please. Okay. Mm-hmm. Okay. So the question is, what is the difference between like using an immutable list from Guava implementation and collections.modifiable lists? If we get collections, modifiable list. You can see that when we're creating a collections.unmodifiable list, basically we're using the decorator pattern, right? You have an unmodifiable wrapper, and inside you have a modifiable list. It doesn't have any problems, it works, but when we're using the immutable list from Guava, it is a list that was optimized for being immutable. So if you have if you're copying if you have an immutable list and you copy an immutable list, it should be like a constant time operation because you can reference the same internal array. So many of the operations on the list are optimized. So that's one of the main points of using an immutable list. But if you don't want to use Guava, it should work. It's just a different implementation because it both results in unmodifiable lists. Okay. And as I said, unmodifiable code. Not all the code that you have can be made unmodifiable, immutable, but you should minimize mutability to the most possible extent. As I said before, the worst bugs, but also immutable classes are thread safe by default, and other advantages. Okay. Anything else? I should have brought some swag because then I could just questions, and give T-shirts back.
You replaced your date method reference with instant.now. Is changing the way
Like this one. The question is that
when you change the implementation,
okay.
then it's not really the same execution.
Because the Lambda way of doing that instead of method ref is that if I have an instant, I'll say instant, and I'll say that instance.now is after instant. This is the Lambda way, okay? And
When will be now? When will it be executed?
Okay. Yeah. So the question is, I have these two different ways of using a bounded method reference, which means bounded method reference means that I want to call this method reference on that specific instance of the object. Okay. So that's why when I say instant.now, I'm creating a new instance. It changes every time. And whenever I create this object, I want to call the isAfter methods on this type. Okay. It could also be another possibility is suppose that I have like a private final instance now receives instance. So I have a now and I have like get now. Needs to be static. Okay, I could use this too. Get now is after instant, and I could replace this for get now is after. Okay, so it's not static, right? Because I'm not calling a static method, and it's I'm calling a method from an instance. So you have two different types of method reference when you're calling on an instance method. You have bounded and unbounded. Unbounded means that I'm calling this method on whenever instance I receive on the lambda. And bounded is I want you to call this method on this specific instance that I'm giving to you. That's what happened. So here, when I say get now, I want you to call the isAfter method on this specific instance that I'm giving to you. This is a bounded method reference. Okay. It's not the same date, actually, isn't it? Here, for the bis.
When you're using the lambda, instant now is executed every time you perform the lambda.
Okay. Oh, but here too.
The first with the previous code.
Okay. Here is the previous version, right?
This one is executing every time now. But with the second version,
Oh, you mean that it would be called just once and then calling? Oh no, it's calling every time. So it's just these two codes are equivalent, right? So yes, I think it might be confusing because one of the ways of thinking that this, I think this, in fact, this is the bounded method reference is the most strange one because you might be tempted to think that, well, instant.now, in fact, this is even weirder because it's a static method. So you might be thinking, well, instant now is called when the lambda is created, then it's cached, and it's always calling isAfter on that specific one. But no, this instant now method is being called in every lambda that you're calling. Okay? So it's not like it's storing it in a static field and just reusing the object. When you're using this, it's creating every time. So these two are equivalent. Okay. So, but yeah, that's a good question because I agree that the syntax can be confusing, especially if you're not used to that. Okay. And that's another point. If you believe that this syntax is clearer for you to understand rather than this one, always choose the one that is easier to understand. Okay. So. Which makes another point, which I forgot to say, that suppose that you have like, let me create a class here, very long class, very long business class name with lots of operations. Suppose you have a class in your system, like you have a Spring Factor, like something that you have like a huge, and you have a method like public void very long method that creates a factory based on integer, and you have this, and then suddenly you want to use that to it's a consumer. Maybe you want to stream dot iterate 0 I plus 1. And you want to perform a for each. And then you just decided, well, maybe I could use that static method because it's a consumer, right? I could go back here and just, well, very long business class name. Oh, you could, it's not readable. Well, maybe in this case it could be better. Well, maybe, well, to be honest, this is no way to be beautiful. But, okay, it's not aesthetic. Whoa. What did I do? Cancel. Okay. Suppose I want to do this. Now, this way I can make it better. So I create a new very long you see var here, it's very useful. Okay. Oh, this version is arguably could be arguably better. So yeah, that's another thing. So you should always choose the most readable version. If you think that it could be complicated, you should switch to use a method reference or lambda whenever it's more readable for you. Okay? Please. Functions? No, you're saying if I have a different method for changing lambda code?
No, no, I talk about the function class in JDK.
Mm-hmm.
It have a default method that is called then to change to function for example.
The function interface has default methods for, oh, this is my function. You're saying, what is the, here. Oh, when you want to compose? Well, in the okay.
Why I can't call this method in the reference?
Why I can't call this method on another function?
No, on a method reference.
Or a method you can't. Why you can't use on a method reference?
Yeah.
I think you can. Okay, because basically when you're providing this default method compose, it just applies an operation before and then just apply an operation after. So you can concatenate your functions. So, but why can't you use a method reference? Okay. Well, this code is going to be complicated. And I don't think I want to live code this failure, especially because it's recording. But we can discuss that later. Okay, then we can explore it here. Okay. So it's going to be lots of generic is, and yeah. So thank you. Any other question? 1, 2, 3. Well, thank you very much again.